Hello, I hope this is working and I can make a video to help you for Algebra 2 Trig. This is to help you with your calculator since I know this is new to many of you, and then you have this as a reference so you can always go back and use it, or you can pause and take some notes if you need to as you go through the questions. So this is our calculator question about an open top box and creating it to maximize the volume. So Frankie has a piece of cardboard. That cardboard measures 20 inches by 12 inches. And so what do we know then? We know that this is your 20 because it looks longer, and this originally is the 12. We're going to remove a square from each corner, right? And we're going to fold that up to make a box with an open top, and then that's going to have a volume because we know that volume equals length times width times height. So when we fold this up, we're going to get a three-dimensional object. So write an expression, or you can write an equation. If you put an equal sign, it's an equation. So v of x equals, so what do we have here? Well, we have this length of 20, but what are we doing? We say that the side length of x inches of square cutouts, that's what we're doing. We're removing this x here, which is the side length of x, or a little tiny bit of x and x. And so what we have left here is we would have the 20, but we removed this x on the left-hand side. We removed the x on the right-hand side, so that dimension becomes 20 minus 2x from here to here. So we have one dimension that's 20 minus 2x. Then we have another dimension right here. So again, we remove an x from this corner. We remove an x from this corner. So the 12 is shrinking down to 12 minus 2x because I removed the x here and the x here. So my second dimension is 12 minus 2x. And then hopefully you're understanding that when you fold this box up, this piece right here, which is the length of x, will become the height. So you should have done this in class. This is a review, but ask your teacher if this doesn't make sense. If creating this equation doesn't make sense, then you should go ahead and ask your teacher for more clarification in person, because it's kind of hard to show you this without the box right in front of us. Okay, so from there, we want to find a reasonable domain. Now, I would actually encourage us to just pause for a moment and maybe skip down here to the graph, because I think if we graph it based on all of the knowledge we've learned so far in this unit, that it will help us to determine what a reasonable domain is. So I'm going to go ahead and start with the graph. So I'm going to do letter D. It says use your calculator to graph v of x, and then sketch the graph below. Label the x and y axes in the context of the problem. So I have my y-axis here, I have my x-axis here, and I need to label these according to the context of the problem. Well, I can see up here that my v of x is my y value, that's my output value, and that's representing the volume in inches cubed. And then we know here this is my x, so I said my x is a result of the side length of x inches cut from the cutouts. So you could write that exact thing. It's side length in inches cut out of the square cutouts. But an easier thing that you might want to write instead is you also know it's just the height. So you could have just written the height if you wanted to instead. Okay, the next thing we know is we have an x-intercept here. An x-intercept, or a 0, is going to be at 10, right? So we know the graph has to go through 10. We have an x-intercept here. That's at 6. So we know the graph is going to go through 6. And we have an x-intercept here at 0. So we know the graph has to go through 0. If you think of the leading term, right? So the leading term, so that's when I multiply. Let's see here. Let me get my highlighter. I'm going to multiply negative 2x times negative 2x times x. Negative 2x times negative 2x times x would give me a positive 4x cubed. And so that leading term is positive, which tells me my end behavior should look like this because it's a cubic and its leading term is positive. So when I graph this, I know that I have to go up through the 0, down through the 6, and back up through the 10. And this is a sketch of this volume function. Now from here, I might want to talk about a reasonable domain. So what is a reasonable domain? So if I look at this, okay, well, your domain is your x values. Now we have negative x values and we have all these positive x values. Well, let's think again what x represents. X represents the height of the box, or it represents the side length of the square that we're cutting out. So can we have a negative side length? Hopefully you're saying no, so I'm going to disregard all of these values. And then you should be thinking, okay, this is representing volume. Can volume be negative? Hopefully you're saying no, so I'm disregarding all of these x values. They don't make sense either. So now I have these x values in between. So I'm looking at these x values between 0 and 6, and then I'm looking at all of these x values as well because my volume is positive. But really, can I have values over here? If I plug in 11, well, that means I'm removing an 11-inch square. Is that even possible in a piece of cardboard that measures 12 by 20 to remove 11 inches on one side and 11 inches on the other? Hopefully you're saying no, that's not possible. The reason it gives us positive volume is because it's turning double negatives. Negative times positive 11 is going to give us a positive volume, but it really doesn't make sense. So the only values that make sense are the values here between 0 and 6. So I'm going to indicate that up here, that x is caught in between 0 and 6. So it's greater than 0, but it's less than 6, or we just do it like this. Now it's exclusive of 0 and 6, because if the value is actually 0, you wouldn't cut anything at all, and you'd still have a two-dimensional piece of cardboard. You wouldn't even have a three-dimensional box. If you had 6, again, if this is 12 right here, 6 minus 6, that whole piece would be removed, so you wouldn't have any three-dimensional box. So it's caught between 0 and 6. Okay, what viewing window should we use then? Well, the whole reason you kind of think of that reasonable domain is to help yourself with your viewing window. So we're going to go to menu. Oh, actually, I shouldn't do anything until I type in my function. So I need to type this into my calculator. So how do I do that? I just open a document. So you go to document, you go to file, you go to new document, you open it. So no, I don't want to save it. You go to graph, add a graph, and here we are. So now I want to put in this function. So I'm going to type that in. So I'm going to put 20 minus 2x, and then I'm going to put 12 minus 2x, and then I'm going to put x. Now some calculators will tell you this is an error. It's because they want you to put a multiplying sign, a multiplication sign right here. So sometimes you might need to go back and put a little multiplication sign with this x. It's confused when it just has a letter out there. So you might need to put a multiplication sign. Okay, when I do that, I push enter. I can't really see the graph, which is why I need to change my viewing window. So I go to menu right here, this button right here. I go to menu. I go to number 4, which is window. I go up here to number 1, window settings, and now I'm going to be smart about the window settings so I can see more of the graph. Well, I have my sketch right here. I know I have a 0 at 0, 6, and 10. Do the negatives really matter? No. So I'm going to reduce those negatives. You can go to -1, maybe I'll go -5 just to see a little bit, but I don't really need to see any of it. If I only go to 10, I can't really get a good feeling for the graph, so I'm going to go beyond 10. You can go to 15, maybe 20. So I'm just going to go to 20. Now think about your y values. Your y values are the volume. I don't know how high up this is going. I don't know how low it's going. That's okay. It doesn't matter. I'm just going to try to guess based on these dimensions. If I have 20 by 12, you could start by multiplying those two numbers together. You don't have to. But yeah, I'm just going to, my negative volume doesn't matter, so I'm going to leave that. And I'm just going to change this to 500, 1,000. I don't know. So I'm going to try it. So here, my 500 includes it. I didn't go down very far, so I can't see the whole graph. But we just said this doesn't matter, right? My domain is the only part of the domain that matters is from 0 to 6. So I only need this portion of my graph. So what is your viewing window? You can make a decision and put that here when you've decided. Okay, now we're going to move on to these questions below because I've already done the graph. sketched it. So now we're going to use our calculator to answer follow-up questions. So the directions we will always give you is that you need to round or truncate answers to 3 decimal places. So round, if you have like 371.8527, well, rounding to 3 decimal places would make this 853 because the 7 makes us round up. If you were to truncate's easier. You don't have to think about it. You just put the 1, 2, the first 3 decimal places, and that's it. So we would accept either of these answers if you had to have an answer that was related to that. So let's go ahead and apply this to our following questions. So the first one, part 1, it says approximately what value of x gives the greatest volume? Well, hopefully you're saying to yourself, I'm trying to find this maximum right here, right? That's what's going to give me the greatest volume. So maybe you want to write that down here to remind yourself, oh, I need the maximum. So when you go to we're trying to find this maximum, so you have to go to your menu, then you have to go to Analyze Graph. And then in Analyze Graph, we're trying to find the maximum. So you might want to write that down, pause, write that down. Menu, Analyze Graph, Maximum. This down here says lower bound. That just means your lowest x value. So I'm going to go to the left. Visually, I can see I'm moving this vertical line. I'm going to go to the left of the maximum. Upper bound means I go to the right of the maximum. I push enter, and I can see that's my maximum. So some of you may not have 3 decimal places. If you don't have 3 decimal places, I set my calculator up to have 3 decimal places, but I noticed some of you, when you turned in your papers, you didn't have 3 decimal places. So that's an issue. You're going to have to be able to take care of that when you're working on a test. How do you change this to 3 decimal places? Within the graph, you have to go to your menu. You go to Settings down here, and then you go to Fix 3. You're probably on Fix 2 or you're on Float. Don't ever float. That's significant figures. We don't want to do significant figures. We want to round or truncate to 3. So you can just do Fix 3 because it's just going to give you 3 decimal places every time. So once you change that, it should automatically change your graph to show the 3 decimal places. So now it shouldn't be an issue anymore. So go back to the question, approximately what value of x gives the greatest volume? So we can see that value of x was 2.427. And so here I'm just writing down the point so I remember. So it's 2.427 inches is the square cutout that I would have to make to maximize the volume. And then for part 2, approximately what is the greatest volume? Well, that would be 262.682 inches cubed. So this is the size of the square I need to remove, or that's the height of the box, and this is the volume in inches cubed. All right, part 3, it says, what is the approximate value of the volume of x if the length of the cutout is 4 inches? So that's, in other words, telling us that x equals 4. So we're trying to find the volume when x equals 4. There are 2 ways you can do that. One is to use graph trace. So I go back over here to my graph. I go to my menu. I go to trace. I go to graph trace. And then it gives me a point down here, but that's not the point I want. So I immediately just type in, literally just type in the number 4, and you see it down here. You push enter, and then it gives you that ordered pair. When x is 4, my y value is 192.000. So what is the approximate value of the volume? Well, it's actually exact. It's just 192 inches cubed. Or if it's 0.000, you can just leave it. It's just 192. Another option that you could do is you could use the table. So how do you use the table? We're going to escape to get out of what we just had. So the graph trace is gone. So I pushed ESC, escape. So to get the table, I can go Control T, and then I can scroll down to number 4. When the input value of x is 4, then I see a table value of 192. Now, if your table's all over the place and it has, like, it's counting by, I don't know, tenths, or it's just not in the right area, you again go to menu, you go to table right here, and you go to edit table settings. You can just do table start. I can just put in a 4. That's what I want to find out. I go okay, and immediately tells me what that volume is if I have an X value of 4. So I can use a table or I can use graph trace. Now this table is kind of annoying. I don't want to see it anymore. So I go Control T and that just gets rid of it. So Control T to put the table up, Control T to make it disappear. And finally, I have this last question, which is a little more complex. It says graph the volume of, or graph this function v of x equals 320. Actually, we're going to make that 220. Apologies, I meant to change that. So that should be 220. So what do the points of intersection mean? So v of x is your y value, right? So that's what this says here. It's my y value is 220. So I'm going to go to tab because I need to graph y equals 220. So I do that and I get this horizontal line and it says, what do the points of intersection represent? Well, not only what do they represent, I want you to practice actually calculating those points of intersection. So we're going to go to menu and we're going to go to analyze graph and then we're going to go to intersection. So I push intersection, I have this vertical line again. I go to the left, lower bound, left of the intersection, and then I go to the right of the intersection. So I have this, and I see that you can hover over that point if you want to move it, and then push down on your cursor here or on that center point until you get the little hand to close, and then you can move it. So I can see that one of my points of intersection is 1.382. I'm going to find another point of intersection. I go to menu, I go to analyze graph, I go to intersection, left of intersection point, right of intersection point. So here's another one. So I see I get 3.618. So I'm writing it over here on my paper. And then I have one more. I analyze graph, I go to intersection, left of intersection, right of intersection, and oh, it's exactly 11. So these are my 3 points of intersection. So if I were to draw that line up here, I would have 1, 2, 3 points of intersection. I'm back over here on this graph. But what do they mean? Well, if you go back and look at our domain restriction, right, it's from 0 to 6. So does this 11 make any sense? Hopefully you're like, no, this doesn't make any sense because if I removed, this is the amount of inches you would remove to get a volume equal to 220 inches cubed. So if I removed a square of 1.382 inches from each corner, then I would get a volume of 220 inches cubed. If I removed a square of 3.68 inches from each corner, then I would, at 3.68 by 3.68, I also get a volume of 220. Can I remove a square that is 11 by 11? No, so if I removed 11 from each side, I wouldn't even have any length whatsoever. So that doesn't make sense. So these two would potentially give me, it would exactly give me 220 inches cubed for the volume. They would work. That is the height in the box, or that is the amount that of the square cutouts that I would remove, but the 11 would not work. Okay, hopefully this helped. If it didn't, you need to continue to ask your teachers questions, come see them, or hit the Math Center. Bye.